Hello everybody, this is Scott Armas. I'm in Vietnam now. A little update on what I'm doing lately. I've been doing research in pure math, and this is my old approach for the p-value of hierarchies. It's from January last year, but this is the first time I tried it out by counting all the configurations with equal candles tau value. You see here the normal approximation doesn't work at all for small values of n, but my own method, fractional factorial p-value, that works pretty well. It's the blue line here. And then yesterday, or was it the day before yesterday? Not quite sure, but I think yesterday is when I implemented it. I came up with a different approach, which I think is more straightforward. And here we have perfect agreement here for n2, and here almost perfect agreement. Well, you don't expect to have perfect agreement for small values of n, because you see the normal approximation does much worse. I think this here, although the deviation might be ever so slightly bigger than before, like this is before, but you see here the deviation may be smaller, but it's a bit irregular here. But here you see in the new version, it's much smoother. You see the line agree much better, like the shape agrees much better. Yeah, well, and now I'm doing the N5. So the way this works is here I have this is the perfect order, A, B, C, D, E. So here we have 4 pairs under A that agree. Here we have 3 that under B that agree, 2 under C that agree, and 1 under D that agrees. And here in the second configuration we have one that doesn't agree. The one after E doesn't agree, so it's -1. One pair that doesn't agree. And here for if A all agree, B all agree, and here for D, C should be above and E should be below, so that's +1 -1 is 0. And here this agrees again, so that's how it works. And then you look, okay, what would be the perfect agreement? That's 4, and 4 out of 4, that's the ratio is 1. So that's our score for the factorial. Here we have the same 1, 1, 1. And here -1 is the worst case here, and so that's 0 agreement. So it's so that's 0. And here we have 0, like that's half agreement, because it's right in the middle of all the possible values that you can have here. And here we have 1. When you look at all the possible values here, you see that it's like 2/3. That the value 1 is 2/3 agreement. The worst value would be -3. So you have to look at all the possible values. Like when you have like 4 elements, you can have for C, the best case would be like these 3 are all agreeing, like not in this case, but it could, so that would be +3. If 2 are agreeing and 1 is disagreeing, so that would 2 -1 is 1. If 2 are disagreeing, 1 is agreeing, that is -1, and if all 3 are disagreeing, would be -3. So then when you see, okay, we have +1, so that is, this case it's like 2/3, and -3, that's like 0/3, so that's 0. and yeah, and here for 4 elements you have this configuration here, and that's how these are the different scores, so you have to pick up the scores here accordingly. And so then you calculate the sum here, and you subtract it from the total number of elements. So here in this case we have perfect agreement, so it's the score is full, so I have 5 minus 4 is 1, so I have 1 divided by all the possible configurations. All the possible configuration that's here, that's the 5 factorial here. And so then here we have 1.75, and so we have to use Google, so we have to put 1.75 here. The Google calculator, it can calculate fractional factorial, so you copy this over here, and you can calculate it. So the result here is 0.013, and you just yeah, wherever we were here, yeah, 0.1134, yeah, that's what I copied here. And while the content below, it's copied from the, oh wait, this is the new version. Okay, so the content below here is copied over from the original version. I haven't finished this one yet. It's almost finished. But yeah, the n equals 4 looks promising, and this too. So I'm going to wrap this up now. Yeah, a few more to go. Okay, that's all for now. See you.